So we're going to be looking at the parameters and the parameter changes to a log equation and what kind of transformation those parameters cause. I have them right next to this exponential thing, this exponential note page, because exponentials and log graphs are inversely related. So that means that if we start off with this equation and we follow the rules right here that we learned for finding the inverse of any kind of function, if we follow those rules right here, we should be able to end up with a log graph. So it says rewrite it with a y. Well, we started off with a y. Step number 2 says switch the x and y. So this becomes x equals 2 to the y. Then it says solve for y. Step number 3 says solve for y. That means get the y by itself. Well, the y is an exponent, so the way we get the exponent by itself, the y right there is an exponent, so the way we get the exponent by itself is we log it. Remember, that just means we convert this equation to a log. Now, if it helps you to rewrite it this way, you can. I mean, because, this is the same equation. It's just that we're putting the exponent on this side. And why? And is it necessary? No. But for some people, it makes it the conversion easier. So this exponential 2 raised to the y becomes log base 2. The base of the exponent becomes the base of the log, and the x and the y switch places. That's how we convert from an exponential equation to a log equation. And so voila, now we can switch it back. Just because we're used to having the log written on the left hand side, we've got log base 2 of x. So this is the inverse equation for this. These are inverse equations. Okay, and we could prove it over here, how to use algebra to prove it. We could say, take this equation, y, rewrite it as f of x equals 2 to the x, and rewrite the other one as g of x equals log base 2 of x, and then we do f of g of x. Remember, that's supposed to equal x. So if we take this f function, which is 2, okay, and then we rewrite it as a log base 2 of x, then these two things, which are inverse operations of each other, cancel out, and we're left with x. The same thing is going to happen when we do it the other way. G of f of x. We start off with the g function, log base 2, and then here's where the x goes. So we're going to put in 2 to the x. Okay, so this is saying 2 raised to what power will give me 2 raised to the x power. Well, again, those are inverse operations, a log and an exponential, so they just kind of cancel each other out, and you're left with an x. So they are inverses of each other. That was really all I wanted to show you. So that means that this equation over here is log base 2 of x. That's what's graphed right here. And just keeping in mind that how we switch the x and y to get from here to here, well, that means that the domain has switched. So notice that now my domain is no longer all real numbers, but my range is. My range is all real numbers because it's headed to infinity this way and it's headed to infinity that way. So I start at negative infinity at the bottom and I'm going to go towards positive infinity at the top, and that means my range is now all real numbers. Notice that those two kind of switch places. Do you think the range and the domain are going to switch places? Absolutely. Because how did we create this? We switched the x and y. So if we switch the x and y, then the domain and range values have switched. So now this one, my domain is starting at 0 because now I have a vertical asymptote. My asymptote now is at x equals 0, not y equals 0, not a horizontal asymptote, but a vertical asymptote. So that means my domain starts at 0, and then it's going to go toward positive infinity because it's going to head toward the right. Like I said up here, my asymptote is now x equals 0. Now, up here, my range, my range is going to be negative infinity to positive infinity for all log graphs. All log graphs. All log graphs will have that range, but my domain is going to change. Now, down here, my range changed when I reflected it over the y-axis. Well, reflecting it over the x-axis is not going to change my domain because my domain is determined by my shifting it left and right. And in Algebra 2, we don't reflect it over the y-axis. You will do it. You will reflect this graph, log graphs over the y-axis in future classes, but not in Algebra 2. So, we don't have to worry about the A causing or changing my domain, but what about D? Remember, D shifts it up and down. So D is no longer going to change. If my asymptote is already vertical, shifting it up and down is not going to change the location of that, but shifting it left and right. So a change of C is going to change my domain, and my new domain will be wherever my C value is. Same thing is true with my asymptote. My asymptote now changes when I shift this graph left and right. And what shifts a graph left and right? That's a value of C. So we do have things changing between domain and range. Shifting an exponential up and down changes the asymptote. Shifting a log left and right changes the asymptote. And then, of course, we still have vertical stretches, and for a log graph, it's going to be a number out in front and being multiplied. Same thing is true with the vertical compression. It'll be the A value will be a fraction. Okay. When A is negative, it will reflect over the y-axis. Over the x-axis. So this end behavior, instead of going down, will be pointing to positive infinity, and then this one will be going toward positive infinity. So that would just be a negative sign out in front. Okay. The C value, you'll have to probably use parentheses to be able to tell the difference. Let's see, if I shift it left, that means my negative is part of the formula, and then I plugged in a negative number. So that will shift it left 4. Okay, and this will shift it log base 2 right 4. And then if I have, they'll probably put the parentheses around x just to clarify that this -1 is not being done to the x but to the log of x. That distinguishes the difference between C values and D values, and it's a good practice to get into to write it that way. So that would shift down, log base 2 of x would shift it up. Okay, so these are the basics of the log graph. Every log graph has an A, a B, and a C, and a D, whether you see it or not. So for this graph right here, my A is 1, my B is 2, my C is 0, and my D is 0. And again, don't let it bother you that I put the Y out in front. You could have written it just like this. Okay, so every log graph has a value of A, B, C, and D, whether they're there or not. I've mentioned in another video that when you see a log that doesn't have a base, it's an understood base 10. So don't forget that. That's called a common log, and that still works with transformations as well. And so this should get you started on the problems about transformations for logs.